What's up, everybody? It's Dan from SageMathTutoring.com and back with another video, this time covering a review sheet, a very kind of messy looking review sheet, but we're going to make the best of it. So looking at problem number, let's see, 1. What is the slope-intercept form of the equation of the line with the slope 1/4 that passes through -4, -8? So for that one, slope-intercept form is such that it's structured this way, where the m is what we would call the slope, and the b is the y-intercept. So we already have the slope for this one, so we could begin the process of constructing the equation to say y equals 1/4 x plus b. But the problem is we do not have the b, so we're going to have to go ahead and find that. And the way to do that is you could use the point that they give you, which is -4, -8. And you can plug in those values, -4 for x, because that's the x coordinate, and -8 for y. So it would become this. We have -8 equals -1 plus b. And then we would add 1 to both sides to sort of cancel out that -1, and then we have -7 equals b. So then we could update the equation further and say that y equals 1/4 x minus 7. So that is how you would do that one. All right, so looking at number 2, which is right here, which is an equation of the line that passes through 2, -3 and 4, -7. So our first goal is to find the slope itself, because if we had the slope, we could then embark on a similar journey that we just did, where we would construct the equation of the line. So we're going to want to find the slope between these 2 points, and the way to do it is to use the slope formula, which says that m equals y2 minus y1 all over x2 minus x1. And in this case, we have 2 points, and the points are 2, -3 and 4, -7. So we'll call that x1, y1. We'll call that x2, y2. Let's see, and then all you'd have to do is just substitute them into the structure here, and that would give you your slope. So we have y2, which is -7, minus y1, which is -3, and x2, which is 4, minus x1, which is 2. So that would become -7 minus -3 is -7 plus 3, so that would become -4 up top, all over 2, also known as -2. So that's the slope of our line. So we can begin the process of constructing the equation of the line to say y equals -2x. We could say plus b. And in fact, since it's multiple choice, we could eliminate these because they do not have the slope of -2 that we're looking for. So from that point forward, you can then use the exact same strategy that we used on the last problem, where we just plug in the point into the structure and then figure out what b is. Now we have 2 points to choose from, so it really doesn't matter. You just pick one. We're going to pick this one because it doesn't really matter which one. And we're going to substitute -3 in for y and 2 in for x. And that's going to become -4 plus b right there. And at that point, adding 4 to both sides would give us b equals 1. And then we could update the equation to say y equals -2x plus 1. And that right there is the answer, so that would make this one the answer. All right, so that's how you do that one. Looking at the next one, which is number 3 right here, it does look like that's the exact same kind of problem. So just use the slope formula to figure out the slope, and then use the exact same strategy to figure out what the equation of the line would be. So looking at number 4, which is the equation of the line with a slope of 2 that passes through -1, 1. Now the equations are written in point slope form. So point slope form is of this structure where it says y minus y1 equals m times x minus x1. And all you need is a point for that, x1 comma y1, and a slope. Okay, now if you have a point and if you have a slope, then you know for sure that you can fill out the rest of the information. So looking at problem number 4, that's what we're doing. So which is an equation of a line with a slope of 2 that passes through -1, 1? Well, the point is -1, 1. So that's going to be your x1, y1. Your slope is 2. And we want to construct an equation like that. So it's y minus 1 equals 2 times x minus -1. Now 2 times x minus -1 is really 2 times x plus 1. So that's what we're dealing with there. Now where is that? Is that in there somewhere? Yes, it looks like it's this one. Okay, so that's how you do that. Problem number 5. Find the slope-intercept form of the equation of the line that passes through -1, 5 and is parallel to 4x plus 2y. Okay, so we want the slope-intercept form, which is once again this form right here. Now, in order to do that, you're going to need the slope and you're going to need the y-intercept. Now, the problem is we don't have either, but we're going to go ahead and find the slope first. And the way that we're going to find the slope is we're going to use this clue that they gave us. They said that the line that we're sort of focused on happens to be parallel to this other line of 4x plus 2y. Now what that means is our line has the exact same slope as this line. So what we could do is we could find the slope of this line. So I'll rewrite the equation over here. It's 4x plus 2y equals 8. You can subtract 4x from both sides and divide by 2. So we have y equals -2x plus 4. So it looks like the slope is -2, which means that if we're going to construct another line in slope-intercept form, we can begin that process now. We can say y equals -2x plus b. And at that point, we have a point, -1, 5, that we know our line passes through. So we could replace this y with a 5 and the x with a -1, and then just figure out what b is. So this would be +2 plus b. 5 equals +2 plus b, and b equals 3, therefore. So when we sort of update the equation once and for all, that's going to become y equals -2x plus 3. So that's that one. Okay, so problem number 6, let's see, find the inverse of all that. Okay, so that's very easy. All you have to do is just switch the x and y coordinates. So instead of 2, -1, it's going to be -1, 2. Instead of 5, -2, it's going to be -2, 5, and so on. So it looks like that's happening here. So that's going to be the answer to that one. Problem number 7, f of x equals 4x plus 3. Find the inverse of f. So all you have to do for that is rewrite the original one only with y equals 4x plus 3 instead of the f of x symbol. Then you switch the y with x and vice versa. And then you solve for y, which would be a matter of subtracting 3 from both sides. We would have x minus 3 equals 4y. And then dividing everything by 4, we would have x minus 3 over 4. Now that is the inverse, and therefore it's right here. Okay, that's that one. Problem number 8 would be the same thing. So we would say y equals 7 times 2x minus 9. Then we could switch the y with x and vice versa. This time we would divide. Well, we have a couple options. Let's distribute. So we would have 14y minus 63 equals x. Adding 63 to both sides would give us x plus 63 equals 14y. And then y equals x plus 63 divided by 14. So hopefully that shows up. Yeah, that should be a 14 there. Okay, so that's that one. Okay, so it looks like for problem number 9, they originally had something like x minus 7 is greater than 3. So in order to solve that, you could just add 7 to both sides, and then you would have x is greater than 10, which is right here. Okay, so that's that one. Problem number 10, same deal. Let's see, problem number 10 looks like it's negative 36 is less than or equal to 3t. So you could just divide everything by that 3 there. And then you would have t is greater than or equal to negative 12. So that looks like it's right there. All right, now looking at number 11. Number 11 looks like it's probably trickier. I'm going to rewrite it down here. Greater than or equal to 4 times 2d minus 3 minus another 3, so we could distribute, of course. We would have 6d minus 3 is greater than or equal to 8d minus 12 minus 3. We have 8d minus 15 over here. We have 6d minus 3. We could choose to, I'm going to illustrate something. So we could choose to have all the d's on the left. So we're going to subtract 8d from both sides. That would cancel. Then we would have negative 2d minus 3 is greater than or equal to negative 15. We can then add 3 to both sides. That would cancel. Then we have negative 2d is greater than or equal to negative 12. Now at this point, we're going to be dividing both sides by negative 2. But you must remember, anytime you divide both sides by a negative number and you're dealing with an inequality like this, anytime you divide both sides by a negative number, you have to change the direction of the inequality. So this becomes d is less than or equal to positive 6. So that's that one. Does that show up in the answer? Less than or equal to positive 6? Yes, it looks like it's this one. All right, so which of the following is the graph of the solution set of m is greater than negative 1 and m is less than or equal to 1? One way of kind of going about that is you could hover it. So we have a negative 1 and a 1. We have something that's greater than negative 1, so we would have an arrow like that. And we have something that's less than or equal to negative positive 1, so we would have an arrow like that. And since it's and, we're concerned with the overlapping region. The overlapping region is right there, so that means it's going to look something like this. So it looks like it's this one here. All right, so looking at problem number 13, anytime you have absolute value equations or absolute value inequalities, you're going to want to make sure the absolute value part is by itself. So in the case of this, you just acknowledge the fact that the absolute value part is already by itself, so then you can move to the next step. And the next step would be to rewrite it only without the absolute value symbols as two separate inequalities. The first inequality is sort of like a replica, only without the absolute value symbols. And then the other one would be x minus 3, only the opposite inequality symbol and the opposite sign over here. So at that point, you could add 3 to both sides. Then we would have x is less than 5. And then adding 3 to both sides here would give us x is greater than 1. So it's the case that x is less than 5 and x is greater than 1. So that means that if you had a 1 and a 5, x would be sort of in between. And that seems to be the case right here. All right, so looking at number 14, which inequality corresponds to the graph shown? So clearly x is going to be sort of between, it's going to be greater than or equal to 2, and it's going to be less than or equal to 4. So the question is, which of these answers would produce that if you were to sort of work them out? For example, if you were to investigate this first answer choice right here, like I said before, you could split this where one of them is the exact same thing, only without the absolute value, and the other is this. And then go ahead and add 4 to both sides here. You would have x is less than 4, and adding 3 to both sides would give you x is greater than 2. And that actually is what's being said here. X is greater than or equal to 2, and x is less than or equal to 4. So that's one way of going about it. Another way of going about it is to always look for the midpoint of this barbell here. The midpoint in this case would be, it would be 1, okay? Now, it's always going to be the case that the midpoint of the barbell is going to be this number here, okay? And it's always going to be the case that the distance between that midpoint and the end is going to be this number here, okay? And it will always be minus. All right, so that's another way of thinking about it. Okay, looking at the next one, which inequality has the solution set shown in the graph? Well, first of all, we should pay attention to the line itself. The line has a negative slope. It's dotted, which means that it's going to be either greater than or less than, as opposed to greater than or equal to, or less than or equal to. It's also the case that the y-intercept is 2, and it looks like the slope is down 1 over 1, down 1 over 1. So we are definitely narrowing it down to these two options here because the y-intercept is 2, and we have that proper slope that we're looking for as well. So the question, though, is the shaded region is above the dotted line, which means that we want to say that, I should say y here. Therefore, y would be greater than negative x plus 2. So whenever the y is greater than the thing, you're going to be shading above the line. Whenever y is less than the thing, you're going to be shading below the line. So that's going to be the answer to that one. All right, looking at problem number 16, which of the following is the solution set of 2a plus 1 is greater than 9, or a is less than or equals less than negative 1? Well, what I would do is I would actually figure out what's going on with this 2a plus 1 is greater than 9. You could subtract 1 from both sides. You would get this. You could divide both sides by 2. You would end up with this. So it's the case that a is greater than 4 according to that information. And then they say the word or. A is less than negative 1. So then the question is, which of the answer choices reflect that? So I like the word or here, right? Because we know it's an or. There's an or there, which is, helpful to know. So a is greater than 4. That's present here, and a is less than negative 1. So it certainly looks like this is the answer. Okay, so that's that one. Okay, so looking at the next one, the solution to which system of equations has a y value of 0? So let's take a look here. What you could do is you could substitute 0 in for y for all of these, and then just see if you end up with, we could say, a reasonable situation. For example, if you plugged in 0 here, it would say that x equals negative 1 because 2 times 0 is just 0. So it would say x equals negative 1. If you plugged in 0 here, well, if you look closely, that would be 3x plus 3 equals 0. You could then subtract 3 from both sides, and then you would have 3x, and then you could divide both sides by positive 3, and then you would end up with x equals negative 1. So x equaled negative 1 up top, and x equaled the same value down in the second equation, so therefore this is the answer. Okay, if you were to plug in 0 here, you would quickly discover that x equals 2/3, and if you were to plug in 0 here, you would quickly discover that x equals negative 1, so that does not check out. All right, so you're basically looking for the system that would produce the exact same x value. Okay, problem number 18. If x equals 5y minus 1 and 2x plus 5y equals negative 32, what's the value of y? Right, so it's basically a system of equations. I'll rewrite the situation here. We have x equals 5y minus 1, and we have 2x plus 5y equals negative 32. And what this is essentially saying is that anytime you see x, you could hypothetically replace it with a 5y minus 1. So that is exactly what we're going to do. We are going to plug in 5y minus 1 over here, and then we say plus 5y, and that equals negative 32. You could then distribute. Next thing you know, you have 10y minus 2 plus 5y equals negative 32. Then you have 15y minus 2 equals negative 32. And then you would add 2 to both sides. You'd have 15y equals negative 30, and then you would divide both sides by 15, and then you would have that y equals negative 2. Now, if y equals negative 2, then you could plug that in here and figure out what x is. So x equals 5 times negative 2 minus 1. That's clearly going to be negative 10 minus 1, also known as negative 11. So that's the other answer. So y equals negative 2 and x equals negative 11. Although it is the case they only ask for y. Okay, looking at problem number 19, use elimination to solve that system. Well, the system is x minus 4y equals 1, and then we have x plus 2y equals 19. If we use elimination, we could multiply this by, well, actually, we could multiply this by negative 1, actually, because what that would turn it into is after distributing, you would end up with this new equation called negative x minus 2y equals negative 19. We can actually kind of forget this one now. And then all you have to do is add the top one to the bottom one. Clearly, we see that the x's would cancel. As a result, we have negative 4y plus negative 2y, which is negative 6y, and that's going to equal negative 18. We could then divide both sides by negative 6, and y equals 3. So that's y. They wanted us to solve for x, however, so what we could do is we could go back to, let's just take this one here, x minus 4y equals 1, and then we could just plug in 3 for y. So it's x minus 4 times 3 equals 1, so it's x minus 12 equals 1, and then we have x equals 13. So that's the deal with that one. Okay, looking at problem number 20 now. Use elimination to solve the system 5x plus 4y equals negative 10. Okay, I'll write that here. And then we have 3x plus 6y equals negative 6. So how would we use elimination? Well, we could aim to turn this thing into a positive 15x, and we could aim to turn this thing into a negative 15x, and that would cancel. So in order to make that happen, you could multiply this one by 3, and then you can multiply this one by negative 5. Now, as a result of that, we'll put the new equations up top, actually. So it's going to be 15x plus 12y equals negative 30. And over here, we have negative 15x minus 30y equals positive 30. And then we can kind of ignore these now. And then adding the top equation to the bottom equation, we would cancel these. You would end up with 12y plus negative 30y, which is negative 18y. And then that would equal 0 because negative 30 plus 30 is 0. Divide both sides by negative 18, y would equal 0. So y turns out to be 0. So if you want to know what x is, well, all you have to do is take one of the original equations. We'll use this one. It was 5x plus 4y equals negative 10. And then plug 0 in for y, and then figure out what x is. So we have 4 times 0 equals negative 10. And then we have 5x equals negative 10. And then we have x equals negative 2. So for that one, y equals 0 and x equals negative 2. Okay, looking at this one here, use substitution to solve the system x minus 2y equals 1 and 6x minus 5y equals 20. So in order to use substitution, you got to pick a variable to solve for right away. In this case, we could solve for x right away, in a sense, solve for x by adding 2y to both sides. So then we would have x equals 2y plus 1. We're going to now ignore this one because we have sort of updated that equation in a way that works for us. What this basically means is anytime we see x, we could replace it with a 2y plus 1, and that's exactly what we're going to do with this one. So that's going to be 6 times 2y plus 1 minus 5y equals 20. So then we have distributing here, we would have 12y plus 6 minus 5y equals 20. Combining these like terms, we would have 7y plus 6 equals 20. 7y equals 14, and then y would therefore be equal to 2. And then we want to find out what x is, so we could work with this one again. And we could say that x equals 2 times 2 plus 1, aka 5. So that's what x is equal to. Okay, so let's see, looking at problem number 22. 22 asks to find the value of y. And what we could do here is we could quickly solve for x because there is an opportunity to use substitution or elimination rather. So you could multiply the second equation by negative 1, and that's going to become negative 5x minus 3y equals 0. That would all sort of get scratched out. And then adding the 12 plus the 0 would give you a 12. These would cancel. The 6x minus 5x would give you x, and then x equals 12. Then we could use that information to figure out what y is. We could rework this one. So we have 6x rather plus 3y equals 12. We could say 6 times 12 plus 3y equals 12. So then we have 72 plus 3y equals 12. And then we could say that 3y equals negative 60, and then y equals negative 20. And that's what they wanted. Y equals negative 20. Okay, checking out this problem here, 23. Your teacher is giving a test that has 12 more 3-point questions than 5-point questions. The test is worth 100 points. Which system represents this information? So you know that when you add all the points up, it's going to be 100. And we could say that x represents the, well, actually, we're not sure yet. So it's the case that there are 12 more 3-point questions than 5-point questions. Let's see. Okay, so that means we're going to be working with one of these because that sentence is talking about the difference between, the amount of questions, and the difference implies subtraction. So let's say that x represents the 3-point questions and y represents the 5-point questions. Then it makes sense that this should work because there are certainly 12 more 3-point questions than 5-point questions because x minus y gives you 12, right? So that's important to know. And it's also the case that down below, 3 points times x amount of 3-point questions plus 5 points times y amount of 5-point questions is going to equal 100 total points. So this is the equation that represents points, and this is the equation that represents the first statement that they made. So this should be the answer right here. Okay, looking at, let's just do problem 25. Use elimination to solve that system. Okay, so we have 4x plus 6y equals 10. We have 2x plus 5y equals 1. Multiplying this by -2 would force us to have a -4x down below. So this will become -4x minus 10y equals -2. And then we have these canceling. We have 6y minus 10y is -4y equals 8. Y equals -2, therefore. And they want x, however, so we could always work with the top equation. We have 4x plus 6y equals 10. You can replace that y with a -2. And therefore we have 4x minus 12 equals 10. Adding 12 to both sides gives us 4x equals 22. Dividing by 4 gives us 22 over 4, also known as 11 over 2. So that's that one. Okay, looking at problem number 26, use substitution to solve the system. So we have x plus 2y equals 1. We have 2x plus 5y equals 3. We can multiply the top one by -2, and what that would result in is a -2x minus 4y equals -2. We could get rid of that, and then these would cancel. You would have a y equals 1. And once you have y, you can just pick any of the equations, plug 1 in for y, solve for x. So we would have 5 times 1 equals 3. Therefore, 2x plus 5 equals 3. 2x, therefore, equals -2. And then x would therefore equal -1. So that's x in that case. Okay, so they're saying simplify x to the third raised to the 8th power. So it's the case that whenever you have a power raised to another power, you could just multiply the exponents. So that becomes x to the 24th, which is the first one. Okay, so looking at the next one, problem number 28, simplify all of that. Well, let's see, that's a lot, isn't it? So I'll just kind of rewrite it over here. We have 36b to the 4th times c squared all over 9b to the -1 times c to the 5th. Okay, so what I like to do with these is separate everything into silos. So we have the B silo, and we have the C silo, and we have sort of the regular number silo. And then taking care of the first silo, we have 36 over 9. Well, that just turns into 4, also known as 4 over 1. I'm going to keep it in fraction form. I would recommend you do that, in general, at least until the very end. So the next silo is the B silo. That's going to be b to the 4 minus -1, because that's a law of exponents, such that if you have the same variable, same base over the same base, you can keep the base and subtract the bottom exponent from the top exponent. So that's what I'm doing here. It's 4 minus -1. Over here, I'm going to do the same thing. It's c to the 2 minus 5. And then continuing on, we still have a 4 over 1. I'm going to leave that as is. We have a b to the 4 ultimately plus 1, b to the 5th there. And then over here, we would have a c to the -3. Now, what I like to do is just make sure they're all in fraction form, unless it's, at the very end. But leading up to the end, we're going to keep it all in fraction form. In other words, I'm going to put a 1 underneath that b to the 5th. And then that c to the -3rd could be rewritten as 1 to the c to the positive third. So at that point, we're ready for the final move, okay? We have everything cleaned up. There's no negative exponents here. Everything is a fraction. And then at that point, we can just multiply straight across. So we would have 4 times b to the 5th all over c to the 3rd, okay? So that should be the answer. Yep, right here. It's this one right here, okay? So that's how you do that one. Okay, so looking at problem number 29, describe how the graph of g of x, blah, 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 is related to the graph of f of x equals 6 to the x power. So really the difference is clearly, so we're sort of analyzing this one and we're analyzing this one, and the difference is clearly this 0.25 part, right? Now, 0.25 is really 1/4, okay? So uh, we could sort of rewrite that g of x as g of x equals 1/4 times 6 to the x. So we have that 1/4 there. Now that 1/4 means that it's going to be a vertical compression. And I know that because it's a fraction. So a vertical compression means maybe the graph might look like this normally if it was just y equals 6 to the x. But if we then say y equals 1/4 6 to the x, well, what that does is it kind of flattens this thing down, okay? So that would be a vertical compression. So let's see what they say here. Yep, right there. Okay, so that's the answer to that one. Now, for the record, if that was a larger number like a 5, like let's imagine we had another thing that said y equals 5 times 6 to the x. Well, that 5 right there would be a vertical stretch, so that means it would be sort of stretched upward now, like that. Okay, so that's that one. Okay, looking at the next one, which is problem number 30. Write that in radical form. So we have a 10 times y to the 1/2. Now, it's important to recognize that that exponent of 1/2 is only being applied to the y. And it's the case that any time something's raised to the 1/2 power, it's really meaning that it's the square root of that thing. So this is going to be 10 square root of y, which is this one. Okay, now had that been 10y with a 1/2 on the outside of parentheses, well, then it would have been the entire thing square rooted. All right, so that's just another example. Okay, problem number 31, we have 5 raised to the x minus 2 equals 125. What I like to do for these is force the bases to be the same on each side. It is the case that 125 is actually 5 to the third. So we can say 5 to the x minus 2 equals 5 to the third. So this part matches that part, which means that this yellow part has to be the same as the yellow part. So therefore, you could create a new equation that says x minus 2 equals 3. Adding 2 to both sides gives you 5, and then you're done. So that is here. Okay, looking at this one right here, which equation represents exponential growth? Well, you know you're dealing with exponential growth. First of all, exponential functions look something like this. And if the b part, the thing that's being raised to a power, is like greater than 1, then it's exponential growth. So let's see. This one's gone because that part's not greater than 1. This is not even an exponential function at all, because in order for it to be an exponential function, the variable has to be in the exponent. Similarly, this is not an exponential function either, because the variable is still not in the exponent. I would agree that the variable has an exponent, but the variable itself is not the exponent, so therefore that's not exponential. This one is exponential growth because we have this part right here that's being raised to the x, and that happens to be greater than 1, so that's the answer to that. All right, looking at problem number 33. Simplify that thing. I'm going to go with the silo method again. It's 6n to the negative 3 times y all over 2n to the negative 1 times y to the negative 3. So we're going to do silos. We separate this part out. You separate these guys. We can separate these. So we would have 3 silos. We have 6 over 2, n to the negative 3 over n to the negative 1, y to the first power really over y to the negative 3. 6 over 2, easy enough, that's 3. N to the negative 3 minus negative 1 is going to go in that one. And then we have y to the 1 minus negative 3 is going to go in that one. Now, like I said, you want it to be in these fraction forms, so we're going to put that as 3 over 1. This is n to the negative 3 plus 1, which is n to the negative 2. I'll just write that. We have y to the 1 minus negative 3, which is really y to the 1 plus 3, so that's going to be y to the 4th. Again, sticking with this sort of fraction format until the very last move. This would become 1 over n squared down below. This is going to become y to the 4th all over 1, right? If you think about it. Now, at that point, we're ready to multiply straight across. So across the numerators, we have 3y to the 4th. Across the denominators, we have n squared. So that should be it. Yeah, so that was like an open-ended one. Yeah, so that's the answer. Okay, so looking at the next one, which is 34, we want to write x squared plus 4x minus 3x cubed plus 6 in standard form. So basically what that means is write it in descending order of the exponents. So the largest exponent is 3, so we would write negative 3x to the third first, plus x squared plus 4x plus 6, and that would be the answer to that one. So that's standard form. Okay, looking at this one here, simplify all of that. Yeah, so I'll rewrite that up here. We have 2a squared times 5a minus 6 minus 5a times a squared minus 3a plus 4 minus 7 times a minus 5. Okay, so then we could just distribute there, distribute here, distribute here. This would become 10a to the third. My handwriting's not good. Minus 12a squared minus 5a to the third plus 15a squared minus 20a. And then we have minus 7a plus 35 there. So with regards to like terms, we have the cube terms here. We have squared terms here. We have just a terms here, and then we have the constant. So combining the blue terms, we're going to have 5a cubed. Combining the red underlined terms, we're looking at plus 3a squared. Combining the green underlined terms, we're looking at negative 27a, and then we have plus 35. Okay, so that's that. Okay, looking at problem number 36, they want us to factor that. So x squared minus 10x plus 9. And what we're really looking for is we're asking ourselves, what are two numbers that multiply to 9, but add to that negative 10 there in the middle? And that would clearly be negative 1 and negative 9. So we're looking at x minus 1 and x minus 9. And that's the factored form of that. Okay, looking at problem number 37, they want us to factor that thing. Okay, that's ridiculous looking. So we have 15g cubed h squared minus 35g squared h plus 40g. So what I like to do is focus only on the numbers first, and I ask myself, well, what is the greatest common factor of those? Greatest common factor of 40, 35, and 15 is going to be 5. So then you could just write that off to the side. Then I would focus on the g terms. And I would ask myself, what's the greatest common factor of g cubed, g squared, and g? Well, the greatest common factor of those would just be g, because g times 1 gives you g times g gives you g squared, and g times g squared gives you g cubed. So in other words, g is the number that sort of divides into all of these. So I would write g. Then I would focus on the h terms. And then I would ask myself, what's the greatest common factor of h squared h? But there is no h here. So we could find a greatest common factor between these two terms. But since there's no h here, there is no way that h could be one of the common factors because this third term does not feature an h, which means we actually found the greatest common factor of this entire thing already. So then we can write parentheses, and then you basically just kind of analyze each term and, in a sense, divide each term by this greatest common factor. For example, 15 divided by 5 is 3. Then we can also say g cubed divided by g is g squared. Now, h squared divided by 1, right, is just h squared. So there's nothing to be said there. So with regards to this one, Negative 35 divided by 5 is negative 7. G squared divided by that G is just G. And then this H has nothing to divide with, so that's just going to remain an H. And then it's plus, we could say 40 divided by 5 is 8. And we could say G divided by that G is just 1. So we don't really have to write that, and we can just close the parentheses. So we have factored this completely by factoring out the greatest common factor. Okay, so now they want us to factor this one. So for these, I would use the bomb method, and the bomb method means you're going to want to explode that middle term, and the middle term is negative 13x. So the way to go about that is you find what I call the magic number first, which is 5 times 6, which is 30. It's always going to be the result of multiplying the leading coefficient times the constant at the end. And then you ask yourself, what are two numbers that multiply to positive 30 but add to negative 3? And you will quickly see that that's going to be a negative 3 and a negative 10, because it is the case that negative 3 times negative 10 gives you positive 30. And it's also the case that negative 3 minus 10, negative 3 plus negative 10, I could say, gives you negative 13. So then what we do is we rewrite the entire situation, except now we're going to explode that middle term based off of the two new numbers that we just got, which is negative 3, but I'm not going to write negative 3, we're going to write negative 3x. And it's negative 10x as well, and then we have a plus 6. At that point, we do something called factoring by grouping, where we focus on one pair of terms at a time. And focusing on that first pair of terms, you factor out the greatest common factor of 5x squared and negative 3x. The greatest common factor would happen to be x, okay? So then you kind of do a similar thing that we did before. You say, okay, 5x squared divided by x, well, that's just 5x. And then you could say negative 3x divided by x is just negative 3. Okay, and then we have this over here. What's the greatest common factor of negative 10x and positive 6? Well, that would be a 2, but it should be a negative 2 because whenever this third term is negative, we want that greatest common factor to be negative. So that's going to be a negative 2. And then you do a similar thing. Negative 10x divided by negative 2 is going to be a 5x. And then you could say this positive 6 divided by a negative 2 is going to be a minus 3. At that point, you're ready to go ahead and separate it into two parentheses. We're basically done. You have the repeat parentheses, which is in red. That's always going to be one of them. So we have 5x minus 3. And the other parentheses is going to be filled with all the other stuff, which I'm putting in blue. So that's going to be x minus 2. And then you're done. Okay. Okay, the next one is sort of complicated right here. I would say this problem, the best way to approach this is to become familiar with a couple different structures. For example, this structure would always yield this right here. And it's also the case that this structure would always give us this situation right here. Now, you might be dealing with like one of these when there's a perfect square here and a perfect square there. Now, that certainly seems to be the case with problem number 39, because I'm going to just kind of write everything here. We have 9x squared plus 48xy plus 64y squared. Now, if you think about it, in this structure, the so-called a is the number that's being squared to give us the first term. Now, the number that's being squared to give us the first term would be 3x squared to give us that first term, right? So we could say that a is equal to 3x. Now, the so-called b right here, well, b is the number that's being squared to give you this term. So the b in this case would be 8y squared, okay? So the b would be 8y, because 8y squared gives us 64y squared. So I'm going to write that off to the side. I'm going to say that our b is 8y. So then the rest is easy, because now that we have our a, okay, we have our a, and now that we have our b right here, Well, then you could just plug your A and B into this structure, okay? Well, actually into, not that structure. You could plug your A and B into this structure, actually. So we're going to try that. So we're going to say maybe the way to factor this whole thing is to just say a plus b squared. Well, that would be 3x plus 8y squared. Okay? Now, that should be the answer. If that's not comfortable, you could always sort of check by foiling this, and you could say, okay, first times first is 9x squared. Last times outer times outer is 3x times 8y, which is going to be positive 3, well, actually 24, right, xy. Similar with the inside, that's going to be plus 24xy. And then with the outside, it's going to be plus 64y squared. So these are two terms that could be combined. We have 9x squared plus 48xy plus 64y squared. And that should be the answer to that one, because that does indeed match this. But the factored form is this, so the answer is in the blue box. The answer to problem number 39 is in the blue box. And to recap, what did we do? We recognize that this is the structure that matches the structure, and we know that this thing would factor into a plus b squared, so our mission is to find the a, and then we could put it there, and then our other mission is to find the b, and then we could put it there. We found our a by essentially taking the square root of 9x squared, and that's going to be 3x. It's really 3x squared to give us 9x squared. We did a similar process. We recognized that 8y squared would give us this. So our a is 3x, and our b is 8y. So then we just plug that into this structure, which turned it into this thing. Okay. Problem number 40. Factoring that, probably straightforward. Yeah, so we're asking ourselves what two numbers multiply to 18 but add to negative 11. And that should be 9 and 9, 2 and 9 probably, right? Yeah, so that would be x minus 9 times x minus 2. Okay, and the reason is because negative 2 times negative 9 is positive 18, and negative 2 plus negative 9 plus negative 2 is negative 11. Okay, so hopefully that was helpful for those of you watching. Just a nice review sheet for a final exam. And yeah, if you have any questions, just let me know in the comments below, and I will talk to you later.